forever loading on data tracker IETF org. Thank you very much.
All right.
And Marcus, am I able to trap you?
On time?
Oh, good, good. Gretchen.
Yeah. Okay. So let's begin. Hello everyone. So Happy New Year. It's welcome to our SCONE Working Group session. This is the second interim meeting in the new year. Sorry. In the new year 2025 and yes. Sorry. I get some trouble. Sorry about that. Yeah, so let's begin. So hope everybody have a good time in the New Year days. And note will apply. It's all about the IETF process and IETF policies. And if you have first time to attend, please make yourself familiar with this. And we also have a code of conduct. Please treat each other with respect. So here's the working group status. And since the last IETF meeting, we already set up the two work stream and for both protocol and also semantic contents of the protocol. And for protocol work stream, and I think we see a very good discussion on the mailing list. And 我在开会，你请你走，我在开会。Sorry about that. And but in addition, we also have a good discussion on the SCONE implementation on the mailing list. In the previous, in the first interim meeting, we bring SCONE protocol problem led by the Marcus to discuss protocol consolidation with chain protocol, and several aspects has been reviewed, such as signal format, signal frequency, and packetization. And I think this is a good discussion. And in addition, we also review one of the interesting proposals on the SCONE experimentation work plan proposal. And unfortunately, actually, this proposal didn't get a wider review after the first interim meeting. So as a working group chair, we encourage more input and discussion on the mailing list on this SCONE experimentation. And here's the goal for today's discussion. And actually, we need to first sort out this administrative, and we need to have a volunteer to take a minute. I see, Brian already called for the volunteer.
Yeah.
Anybody to help?
So I am also I am willing to help take minutes. One of the nice things about not, being up at the front of the chair is that you can do that. I see that Marcus is.
Yeah, I think I will be driving a few slides, but if we can kind of do a joint, then it should be fine. Yeah.
Yep. So is anyone willing to back Marcus and I up when Marcus and I started arguing with each other, me obviously as an individual at the mic? Yes, no, maybe. Ted, thank you.
Thank you. Okay, so the goal for today's interim meeting will focus on progress the protocol workstream, and we spend a lot of time to to discuss how to converge this various different protocol proposal. And I know it's a little bit painful actually, but I really the end goal is to come up with the baseline foundation which we can build on top of it. And in addition, we will review the progress of semantic workstream. And in this interim meeting, we receive a very interesting proposal, which will take us to explore the consistent way to represent the throughput advice semantically, which allow both network side and endpoint side to measure stream data rate consistently. Here's a meeting agenda for today's discussion. We break it down into two parts. The first part is protocol workstream, and we have two topics. The first is open discussion on merge protocol proposal. We'll spend 60 minutes for this topic. I hope this will lead by Marcus and also Christian. The second topic, we will discuss a new proposal. It's leverages the user plan function for network side advisory signal. This is more related to 3GPP work, so really take us to explore how SCONE work can be integrated into 3GPP architecture. And for the second part, we will discuss video session data rate for SCONE protocol. This is a brand new proposal, and we hope have more eyes on this proposal, and hopefully we can have a good discussion on this. Without further ado, and let's move to the first topic. Marcus.
Okay, let's see. Yeah, perfect, sharing that. Yeah, so I will kind of quickly go through. So Matt and I were the original authors of the first SCONE kind of strawman proposal, and then there's been a lot of discussion on the differences and similarities between SCONE and Train, and kind of as authors of SCONE, this is just some thoughts of what we see quote-unquote merged proposal could kind of look like. So next slide, please. So we believe that we like the communication model from Train. It has several nice properties that SCONE didn't have. So I think one very important aspect is that both quick endpoints are aware of the SCONE or SCONE Train interaction, so they negotiate support by sending transport parameters. So SCONE had the property that you might end up with sending SCONE packets that are received by an unsuspecting server, and we don't know exactly what would happen in that case. So this is we believe this is a sensible thing to do. We also think it's fine that these packets are bound to end-to-end quick packets. It does, to some level, help against certain kinds of spoofing. It's not foolproof, but it has some properties of anti-spoofing that are desirable, and it also kind of removes any ambiguity on sort of to which quick or which connection these kind of train SCONE signals refer. So we kind of agree with this model. Next slide, please. One aspect that oh, sorry, one back. No. Yes, this one aspect that was an important distinction between SCONE and Train was that in the SCONE proposal, it is the network element itself that determines when a new signal is kind of generated and sent out over the path. Whereas with Train, it is the endpoint that probes the network for new signals. So it inserts Train packets into UDP datagram, and then anything along the path that is capable has the possibility to look at that and then modify it in order to negotiate or indicate a rate. Now, we believe that there are cases where it is desirable for a network element to be able to send these messages unsolicited, sort of. So because there can be changes to policies that happen quite immediately. They don't happen frequently, but when they happen, you want to signal that as quickly as possible. So some discussion between us and the Train authors resulted in that it's actually already possible in Train that a network element always has the capability of inserting a Train packet into a UDP datagram that contains an end-to-end quick packet. What you need to do in this case is that you need to expand that UDP datagram prior to forwarding it, and that might not always be possible. But you have the possibility to do this, and we believe that a merged proposal draft should explicitly describe that this is a possibility and discuss it. So it's good to be explicit that this can happen and discuss it rather than network elements experimenting and figuring this out by themselves. So that's another aspect we want to cover. I see that Miri is in the queue. Do you want to comment on this or?
Yeah, actually, I mean, yes, you can do that if there's, as the text says, if there's space in the packet, but that's rather unlikely, right? If you're sending some traffic downlink, you will usually, like big files or whatever, you would always send full-size packets.
Right.
So how do you even know the MTU?
Yeah, so that comes to later discussions on other aspects of the protocol, which I think we can punt to later. But yes, in many cases you might have difficulty in expanding a packet because you might be using full path MTU, and of course it depends on the where the network element is and its knowledge about the path from itself towards a client and so on. But yes, it's.
So what I'm saying is, I think in the general, like in a very likely case, you cannot do that because there will not be space, or you don't know if there's space. So if we want this property, I would rather like to see an explicit mechanism to support this.
Yeah, that's also a possibility for discussion, of course, that we could. But at the very least, we want this to be described. Christian? Yeah.
Just a point about packet lengths. The network elements do not, in fact, know the packet lengths, the maximum packet lengths that will be acceptable by the endpoint. The quick protocol does negotiate a maximum packet length acceptable by the endpoints in the transport parameters, and the network elements do not do that. So Miria is correct that in most cases, what the network will see will be packets that are up to some size. That size can be either limited by the MTU or limited by an end-to-end process that the network element doesn't know about.
But you don't extend the end-to-end quick packet, you just add another one to the datagram, but you don't
the datagrams,
MTU.
Miria, what I'm saying is the datagram size is limited.
Yes.
In the same way.
Not in the quick layer, but underneath, yes.
Yes.
In practice, yes.
Of course, and it kind of depends on in which direction you're sending signals as well. If you're sending signals along a more kind of ACK path, then you often have more capabilities of expanding those datagrams more safely. But then the question is, what could you use for the signal in that direction? And that I think that comes back to later discussions on what more we can do with the protocol. But yeah, this is one option, and I think it's like this is. To be clear also, what we're talking about here is a starting point for something that the working group can adopt. And I think there are a lot of questions like this that we need to resolve as a working group. But what we want to come to is a point where we have all the discussions like focused either like on the mailing list and GitHub. And right now, I think, yeah, these are some of the minimum viable stuff that we would like to see to get to that point at least. Yeah.
So I put myself into the queue with my chair hat on to say about half of what Marcus just said. Yeah, I do think we're primarily getting to we want to have a basis document because things will go faster there. I think I'm reading this discussion as we think we have this requirement. But we do know that like actually building this will be difficult, right? We don't have to solve that to adopt this document though.
Yeah.
Or to adopt this approach, I would say. Yep.
Yeah. That's my description. Yeah. And then next slide, I think that's maybe a more contentious issue, as we've seen by recent emails as well. One big difference as well between the train and SCONE is where and how we encode the rate limits, the information that can be signaled by this protocol. So in train, it makes use of the first header byte of the train, the long header packet, and there are 6 bits available there that it uses to encode the signal, and these bits can then map to values that are defined in some table, and then you get 64 distinct values you can communicate with this protocol. We believe that while yes, 64 different kind of bit rates, that covers a lot of ground, but we are a little bit worried that it might be too restrictive, and that depends quite a lot on the discussions we will have about the semantics of the signal and so on. Are we fine with simply expressing a bit rate, or do we want to associate other properties with the signal as well? Like, do we want to be able to say something about how the network is averaging this, and like what windows it's using to consider these bit rates, etc. There might be many things you want to express. So, and on top of that, there is also a quite wide variety of network policies out there, and maybe they could all fit into these 64 values, but it's quite hard to say, and it's always a little bit difficult to kind of predict these kind of things when deciding a protocol spec, and will these 64 values still be sufficient down the line if this gets more widely deployed. So we believe that having explicit throughput advice gives you more flexibility in actually setting the values of it. And it also frees up bits for other purposes. Maybe, there have been some proposals floating around for endpoints kind of indicating that they have received throughput advice. Maybe you want to use bits for that, etc. There could be other uses for the bits that are not just signaling throughput advice. Of course, moving the signal from that first bit, which is at a fixed location in the packet, to a location which comes after a variable length field, means that it will be more expensive. It will take a bit more processing from the network element to find and update the throughput advice. So that is something we should be conscious of, and it adds a bit of per packet overhead. But I think these aspects depend a lot on how frequent we think that this signal will be. Like, if we take one extreme, which is ECN, where you send signals per packet, then it makes very much sense to have a small amount of bits for the signal, and you have them at a very fixed location, so you can do fast processing of that. In this case, at least when we're looking at the video shaping / throttling use case, the perceived frequency of signals is very, very much lower than that. So I'm not sure we need to restrict ourselves in the same way as you would in something where a high frequency of signaling is expected. And I would love to hear some comments and discussion on this. Christian?
Go ahead.
Well, do we want to have that discussion now, or do we have some time in the agenda specifically for it?
Yeah, what's your last slide, Marcus? Is that, because I think this is one of the primary things we want to keep discussing here, right? Like, I mean, there is the discussion going on in the mailing list, and I would like to use this time to continue that.
No, I think we can do it now. I think there's not much more we want to discuss, to be honest. So it's this and the previous one, and yeah, but this is an important part. So please go ahead, Christian, if you have.
Okay, so you did not mention an interesting property of train, which is that the advice is kind of comparable between multiple points on the path. That is, you assume that there's just one point setting the policy, but in fact, it can be one of many. You can have a congestion point near the sender. You can have one near the receiver, for example. That's pretty common.
Mm-hmm.
And if you do that, the way train works is that each point is supposed to compare the value they want to insert to the value that is already in the packet.
Yeah.
That means that those values have to be in some kind of ordered space. I mean, regardless of whether they're 16-bit or 5 or 32, they have to be in an ordered space so that you can do a comparison operation between the value in the packet and the value you want to insert.
Yeah. Absolutely. I think that's an interesting property, and I think that's fine in both of these models. It depends on the nature of the throughput advice blob you have there, but even if you have a more explicit value there, you could do a comparison operation there. Of course, it's more, if you expect that there are more things along the path, it's maybe more expensive to do the comparison down there. But there is also one thing I was thinking about what you could use the bits for, and is that if something along the path changes the throughput advice there, you could actually flip one of the bits up in the reserved bits there to indicate that something along the path has touched this packet, and then you know if you need to go in and as a network element, you need to go in and compare and change something or not. But yes, yeah, that is an interesting property. Another thing that I didn't put up on this slide is that there have been discussions around the risk of misclassifying train packets, seeing other packets that have the same signature as a Tron packet, and misclassifying that, and then kind of changing some value, and then pretty much damaging those packets. And by the discussions of potential mitigations to that, to those kind of issues, it looks like you probably will need to do some additional parsing of these packets anyway, probably jump beyond the connection ID fields. So if you anyway need to do these, take these actions, I don't think that the overhead of having the throughput device at that layer at that point is that much.
Well, there are two separate issues. One issue is essentially, can we implement that in? Yes. Okay. One issue is whether we can implement that in hardware. And that's a whole line of discussion that has some constraints. I was just trying to insert the other constraint that we have, is that you do not have a single policymaker in the past, you have many. Okay. And because you have many, you have to have a composition process. The composition process in train is very simple. It's a comparison operation. If you want to have a more complex comparison process that has a cost, and we have to be very well aware of that.
Yeah,
in particular, I'm worried about how do you compare the fact that, hey, I can do 20 megabits per second and I look ahead 20 packets versus I can do 19 megabits per second, but I look ahead 5 packets. I mean, if you put multiple dimension in your data, the comparison operation become really hard. And in fact,
I agree with that. That becomes a much more difficult problem. And then I guess we come down to the expected deployment of this. Do we foresee that this is the common case where we have multiple multiple policies along a path, or do we more see this suited for like typical last hops of a path? And I guess that's
But
that's a
it's,
question.
yeah,
What
and even if you think of the last hops, there are two of them on each side. And so at a minimum, you have to assume there will be one on each side making decisions. So I think you cannot avoid the composability issue. And the composability issue is just one of the facets of what you get if you keep the damn thing simple. That was the point I wanted to make on that particular issue there. I mean, on the signal, on the size of the signal, the scope of the signal, the structure of the signal, damn, we should really keep it simple.
Ted, are you having a separate one? Because I would like to reply to Christian.
I'm also building on Miriam, so I'd like to go down.
You're breaking up for me, Ted.
I said I'm building on what Christian said, so I'd like to go now. I think if you are going to comment and reply to Christian, you're probably also going to have a comment to reply to me, so you might as well leave it where we are. First, I think Christian's exactly right about the placement of this in the packet being important for whether this is easy to do in hardware or software. It's certainly possible to do in hardware with more complexity, but it is expensive. And it tends to be something where once you've implemented something that complex, it's a little bit harder to change because you kind of created a fragility there. The other point, however, I wanted to kind of build on his point about composability is that at the end of the day, we want this to be consumable by the application. And the advantage of Train's approach is the composition is in effect a substitution. You're going to end up with the most restrictive thing along a fairly simple space being the result of the composition, and the information going to the application is easier for the application to act upon as a result because it's getting something in a single signal within a known.
Did we lose Ted entirely?
I think we might have lost Ted.
But he was anyway very hard to understand.
Yeah.
So actually, Ted, if you can hear us, can you put that point into the notes and we'll move on to Miria?
Yeah, Ted, we can't hear anymore. And I would recommend to put it in the chat.
Yeah.
Okay, can you hear me any better now?
Yeah, but you're still breaking up a little bit.
Yeah.
Okay, well, we'll just put it into the notes, but the core thing is that the application's ability to act on this means that the composability being as simple as possible has a great advantage. And I think us trying to account for multiple policymakers who are going to do something other than substitute a more restrictive policy is going to result in a difficult deployment on the application side.
Okay, yeah, got it. Yeah, and I think definitely, I agree. I think anything other than kind of substituting, if you have something more restrictive, then you indicate that. Otherwise, you let it be. I think that we're in agreement with that. Yeah.
Yeah, exactly. I just wanted to make this point as well. So, like, you always just compare the rate. If you have a lower rate, then you just substitute the whole thing. That's the thing. So that should be replacing the whole thing is as easy as replacing just the rate. So I think that's actually no difference. The other thing I wanted to make, I forgot. What did Christian say?
Go ahead and put yourself back in queue. You'll remember it.
Should we end it?
Yep. Abhishek.
Yeah, even though I see the point about simplicity But one thing I wanted to sort of challenge a little bit on what Christian was saying. The majority of this problem arises in the mobile network, uh, and at least in mobile network architecture, and hopefully some of this should be clear from the slides that Sanjay is going to present. There is one capable node that has access to all the subscriber plans, and which is the user plane function node, which is what will be inserting these packets most of the time, the rate advisory packets. Now, in theory, we can say that everything along the path can insert these, but at least in mobile network architecture, there is one very capable node that has all the information that they need to insert such an advice. So just wanted to mention that. I do appreciate the discussion around simplicity versus flexibility, but just wanted to mention this. Thank you.
Yeah, makes sense.
Can you guys hear me?
Yeah.
Great. Hey, Marcus, your audio is, I think, cutting into other people's audio. So you could mute, please. I got in queue to say, I think people have made a lot of interesting points about like some of the trade-offs here for having like rich or sparse information about throughput. And ultimately, we're going to have to do some experiments and argue about this later when we get data. And I would recommend that we, for this draft that we're going to adopt, we just have like throughput advice length there where it says TBD, and then let people put blobs in there for experiments, and then come back when people have data that like we can actually do something with all these bits.
So yeah, I was gonna plus one what Martin just said. That's a great idea. The other thing I wanted to bring up is that on this discussion of composability, I think we should ground ourselves a little bit on how big of an issue that is. Gory mentioned this in the chat, but just like from a realistic point of view, just like as people who observe that these policies, we don't see cases where there are multiple very often. The vast majority of the time, the compelling use cases here that have been like this for years are where there's one element that's imposing policies like this, and there doesn't seem to be multiple. And this kind of makes sense if you think about how, like Abhishek said, especially mobile networks are architected. There's just not a lot of places where there would be multiple devices doing this. And so while composability, yes, is a theoretical concern, and it's certainly worth having texts and discussions about, I don't think should be a primary reason on deciding between certainly encodings of the advice, because just in practice, we don't really see that that's going to be a problem. Whereas some of these extensibility questions and flexibility of the signal, that's much more likely to pose deployment problems insofar as it may stop this from being usable. So I just wanted to make that point that, like, yes, composability is something we should talk about, but it probably shouldn't enter into this as as Gory said, as a showstopper.
Yeah, so I actually did remember my point. It was about this fast processing. So this is not a per packet signal, because ECN came up as an example where you actually need to mark every packet and you don't have state or whatever. This is per flow signal, so you might have state anyway. And especially when you compare it to shaping really needs flow state. So you cannot, this is not implemented somewhere in the middle of the network. It's always somewhere at the edge where you have like a limited number of flows. You can actually do per flow processing. And that's the assumption here. I think we don't want anything like this, like in the middle of the network. We always want to have it at the edge. So I don't think there is actually a question about fast processing here. And then I would like to make another point about flexibility. Yes, we can do experiments or whatever, but I think even if we know what's happening today, it doesn't tell us what's happening tomorrow. And especially the application space in media is like a so quickly changing space that I also don't want to make guesses about what's happening tomorrow. So even so, you know, we think like huge values are unrealistic or whatever. I really don't know. So I think we should just we need some flexibility here, no matter what. And I don't see a reason why to limit ourselves to just a handful of bits. I mean, like, there's nothing in the protocol design that actually makes it better that way.
So I think I saw a nice, yeah, it seems like we hear a lot of discussion that we should do both initially, and we can do experiments, and I think that's fine. I would be happy to implement something that does both of these things for Bangkok, for instance, to do testing if people are interested. But we need to get to a point where we agree on what to implement. And Kristen, yeah.
Yes, another point of design is, do we want to do this modification in place, or do we want to extend the length of the packet? And basically, Train did go for modification in place, and that is what allows us to have coalescing of multiple packets.
Yeah.
If you do not do modification in place, basically it becomes very hard to coalesce multiple packets. That doesn't work so well. And so that means that if we go for the kind of a blob or a composition of a tag and a blob, which is basically the classic IETF things of doing both things, we have to make sure that the blob size is actually fixed.
Yes.
And that the client reserves the bits in the that the sender of the SCONE initial sender of the SCONE packet reserves the bits, so the modification in place can happen.
Yes, I think that is a strong requirement for this to work. Yes, you don't want to expand packets just to insert the signal. I agree.
Yeah, but that means that things like having a TLV or having multiple things added one to the other, that doesn't work. I mean, let's be clear.
Yeah, no, you're definitely constrained in what you can express, like how you can design this blob, right? And what it consists of. But that it has to have a fixed length, I think, is the total blob needs to have a fixed length, and whether that is consisted of some padding or something initially, that's one thing. But we cannot keep changing the size of datagrams. I think that would be very poor design. Yeah.
Okay.
So I think we've drained the queue. Do you want to go on to the next one?
Yeah, the last slide, I think that's just more like, yeah, if you go to next. Just want to say that let's get started, because I think there are many interesting things for us to work on as a working group, and get like this throughput advice format. We have started to have good discussions, and I think a great way forward would be to allow us to do some experimentation. That would be a great step. We also need to think about minimizing the risk of misclassifying packets. We have seen discussions on that. I've seen some ideas floating around on endpoint acknowledging receipt of advice and things around frequency of probing, and maybe can we make network elements influence endpoint probing frequency somehow. I think that would be great things to discuss, but I think I would like to punt most of these discussions for later. I really would like us to adopt something, so we really can get started working on some of these basic concepts. So, from at least from what I heard, I think it would be a great idea that we might start off implementing both. We can have a TPD, or we can have some kind of throughput advice blob, and we have the 6 bits, and that allows us to do tests and experiments. I would be very happy to do an initial version like that. Ben?
Yeah, thank you. I support the idea of actually starting with both, for the very reason that frequency is actually quite important subject, and requirements around efficiency should be on top of our priorities. And I think we can do a notification like with fixed length, messages, and to basically be supported with a more flexible blob where the policy changed. So I can see the benefits on both sides. As many people said, these things don't change very often, at least for the purpose of some of the policies that are associated with intentional policies, that are built into subscription plans and other things. But I think the idea of actually using a push notification concept or framework would be interesting, at least for me.
Christine, go ahead.
Yeah, the point with any push, really, Marcus, you should mute your audio when you're not speaking because there is a lot of saying. I understand why people think that the network wants to be able to tell you stuff all the time, but the huge tension there is security. Because the more you allow the network to inject information, the more you allow third parties to inject information as well. I mean, there is kind of in the absence of an authentication channel between the endpoint and the network element, the packet injected by the network are indistinguishable from packet ingested by a third party. So that is really the crux of the issue. If you find a way to do that securely, that's one way. The other way might be to have a difference between the packet injected by the network and the packet that are going through the endpoint. Because, I mean, logically, if we believe security, like what I was saying in my email, there is nothing that prevents an element to do a train packet in the train proposal. The only thing that prevents it is that the endpoint will do some kind of check using heuristics or whatever that are very likely to reject whatever is not concatenated with an actual end-to-end quick packet. So that check is not going to disappear because we wish it. That check will happen all the time because if network messages are undistinguishable from third-party messages, you need to do that. So this field, you cannot just say, I want to send messages, thus I will send them. You have to say, I want to send message. Yeah, fine, I want to do that. But I want to do that in a way that the client will not reject them. Otherwise, it's just flogging the tides.
Yeah, no, I agree, and I think we're not proposing sending separate train packets that are Tron packets that are not sent in UDP datagrams that contain quick packets. Then the question is how easy is it to expand a datagram that is already containing data and so on, and that's something we need to consider. Other ways around this would, for instance, be if a train packet can indicate, because train packets are unidirectional in that sense, right? So if a train packet could indicate in one direction that you would like to see a probe in the other direction, that could be a nice feature. So then the client could, for instance, send to the server, say, hey, I think you need to send more probes, or the network element could actually insert a train packet with that indication into an uplink packet, stating that I need. It would be nice with more probes, and then it's still the end-to-end decision to insert probes or not. So I think there are possibilities to get around some of these issues, to add some flexibility in signaling, but still maintaining the properties that you're talking about, Christian.
Well, if I may jump the queue and respond there, I mean, nobody is going to be angry with me. What I have always looked at there is that train or drone are not in isolation. They are part of the feedback the network is giving. We already do have a mechanism which is very standard to have feedback on the network, which is the ECN. So in the original train design, we are thinking that the bandwidth indicated by train is basically some kind of pre-program, something like, for example, the similar to the capacity limiter that is in my broadband router that says, no, Christian, given your subscription, you're not going to be sending more than 75 megabits. Okay, that's one thing. And then there is the real-time changes, like, damn, I have way too much load, which is what you do with ECN bits. And this relation between, and the ECN bits are supposed to be in certain use and a thing that you change all the time, etc., based on the current condition. And there is some dynamic that we have to understand between what is to be done with mechanisms like ECN, which are reactive and depend on instantaneous conditions and are a way, an existing way for the network to provide real-time feedback to the application. And mechanisms like train, or drone, which in my mind are kind of slower. Okay, so a lot of the discussion, I forwarded Martin's comments on the train issue on the mailing list, but one of the issues is how to compose these congestion signals sent by the network and the drone information. And in particular, we can very easily have a suggestion that the endpoint take any kind of congestion notification as a way to say, hey, maybe I should poll again for SCONE. And that would probably be the nicest way to, excuse me, that would be a very nice way to trigger packets when conditions change.
Yeah, I agree that sounds nice. I think that might cover parts of the issue, but I think there are, because yeah, I agree, like train or drone is really about setting like an upper bound. Like, yeah, you only have 75 megabits per second. That's the upper bound. The ECN is more about reflecting the actual conditions, because, and especially in wireless networks, I think this matters a lot, because you might have a policy that states that you can have maximum 50 megabits per second, but you might be roaming around in channel conditions that allow much less, and then ECN is tremendously useful to actually to do your proper congestion control in these conditions. And I don't think the ECN signals you get in this condition are indicative that you have kind of changed your upper bound on kind of the drone level, which is more around kind of the policy of the network you're attached to. But you might have a handover from one region to another, or one where, like, one tracking area or similar, where the policies might be different because of more global network policy, and that so you might go from one area where you have 50, and then, you know, because of various conditions in the operator network policy, you might go to a place where you have 30 megabits per second, and you want to use it. You want to send a new train, drone, SCONE signal to indicate that, and it's just the same. It indicates a new upper bound. What you actually get, what the channel conditions are for you might still be way lower than that, and you use ECN or whatever other congestion mechanisms you use to do your congestion control. So while I think it's interesting to think about how ECN could influence the, you know, your path probing with train, I'm not sure I'm not sure it's that clear cut that you could use that the increased ECN signaling as a heuristic to think that you will get new rate updates on the train level. Yeah.
Well, I was thinking congestion. I was thinking congestion information in general, being packet loss or ECN or excessive delays. I mean, that's. But basically, having advised that the client has been receiving a bound from the network, congestion control tells it that, well, we are not operating at that bound, we are operating at something else, is a nice signal to do the test.
Sorry for jumping the queue, but I think it's actually not. You should really keep these signals separately. Like if you have a SCONE signal, in a lot of cases you will not be at the congestion boundary, so you don't need congestion control in that sense. If your congestion control jumps in, then congestion control takes over, and you shouldn't really bind your SCONE signal on like the same kind of input as your congestion signal, because that's just a recipe for failure. These signals are really independent, and we should design them independently.
So conscious of time, thanks for that. Conscious of time, we've got 15 more minutes. I want to see if there's anything else that we want to dig into here in order to give us as chairs an idea of how we want to go forward.
Yeah, I'm still in the queue for something else.
Okay, yeah, that's one of the things.
Okay.
So
Okay.
I think one of the things that I have heard with respect, hold on, let me scroll back in the notes. It took a while. I think I did hear that there is not a lot of understanding about sort of like what the update frequency or the change frequency regime that we're dealing with here, right? Like, so I've heard like, oh, we want to be able to push, but I don't know what the underlying change frequency requirement that drives that is. That's something that I think needs to be clarified as we make a decision about like sort of how these mechanisms interact with each other. I didn't want to jump in and like break that discussion because I think it was super interesting, but I think we do need to understand it's like, are we, and I would like, I think, you know, if I said, oh, we're going to be in a regime where we're going to be changing the throughput guidance on a sub-second level, I think that would get Myriad to stand up again and explain to me how congestion control works. And she'd be right. So I think we do need to get an understanding of sort of like what that time scale is, because some of those time scales, it's like, okay, you can just wait. Some of those time scales, you're going to need some way to determine you should reprobe. Some of those time scales, it's like, don't do this. That's what congestion control's for. So I think we should write that down and move on. Miri is in the queue for something else.
Actually, now that you talked so much about it, I want to comment on frequency. I think frequency is the wrong term here as well, because it's not really about how many information you send. We should really limit that to a minimum. And it's not about a frequency. It's really like when exactly you need the information. When there's a change in the network, you should as fast as possible send this. And this is not happening in a frequent or whatever. It happens because the user is moving to a different cell or whatever. So the only entity that knows about this is the network. And it might not happen forever, right? Or it might happen every 3 seconds, or I don't know, usually not with a frequency. So that's one thing to consider. But my actual point was also, we're trying to design for a lot of cases where, like Christian talked about, having multiple bottlenecks or whatever, and so on. But I think we should really make sure we design a protocol that really works for the one important case that we know about, which is we have exactly one shaper, which is in the access network. And that gives us a little bit different properties, because having it in its access network also means that we could, for example, filter out if we see something from another element that's further back on the path, because it shouldn't be there, and these kind of things. So like, I think we should really concentrate in this case and make sure we design the best protocol for this case. And that would give us, in terms of security, maybe also some different considerations.
Go, Christian.
So the word you're looking for is timescale. Okay. And what I've heard in this discussion is there's a tension between what the timescale is that we want to look at. There is a timescale which is, hey, I am going to say a Wi-Fi hotspot, and I'm learning what kind of throughput is available on that Wi-Fi hotspot. That's one kind of time scale. There's another time scale is I change network. I mean, I pass the border, or in my case, I move 10 kilometers, and suddenly I'm connected to a network in Canada. And being connected in Canada, I don't expect my limits to be quite the same. So that's one kind of time scale. Okay. The other time scale we have heard is I am moving to a different cell, and that's you're going to move to a different cell. You're in a train. You're going to move in a different cell every 2 seconds. I don't know whether we want to have train be the mechanism to handle that, and we have to be clear there.
So I think you're still mixing up congestion in the signal a bit, because like you said, for example, on a Wi-Fi, you want to learn what's the maximum rate. You shouldn't learn that. You should figure out, I'm operating this Wi-Fi, I have this user, this is the rate I can give you, because, and the actual rate might be below or above that, but this is the rate I'm limiting you to. So that shouldn't be depending on the current congestion state. Similar for a cell, right? I was bringing the cell example, not because you want to change the signal with every cell, because every cell, of course, is different, has a different load. But maybe you want to change it when you actually go to a cell that is like whatever in an urban area where load is usually much higher than in all my other cells. And that's where it makes sense to provide a different signal. But that's nothing that you learn based on the current state of the network, because that's congestion. But that should be independent.
Well, first, one thing there is not clear. The same way the time scale were not clear. The draft, the working group should actually discuss the issue of what is done by congestion control and what else is done by train or drone. Because this question is going to come back all the time. Okay.
Yeah, I think that is a good point, and I think we should discuss timescales. I think it should be super clear what timescales we are considering. I think for a lot of us who's been involved in this work since a long time, we in our heads have clear ideas on the timescales. But I agree with you. It should be very clear, explicitly described in the draft, like where do we draw the line between what we're thinking of here and where do we start touching upon things like congestion control, and I think making that is good.
So then there is two other points that Miria was saying. First, Miria was saying, hey, if I am in a Wi-Fi hotspot, I don't expect the Wi-Fi hotspot to give me the drone or SCONE or train feedback. Why wouldn't I not? I mean, that's clearly some guys who are setting policies, and they may want.
Sure, you can get it, but I wouldn't expect it to get it based on the current throughput rate. It's a signal that is based on your subscriber or on whatever, but not based. You don't measure something in the Wi-Fi and make then a decision.
No, that's not what I'm saying. In the case of you are in your hotel room and you are going to your hotel room, and the hotel room tells you, you know what, Miria? I mean, for you have not booked a suite today, so you have only 5 megabits. That's
sure. Yeah.
You'll see that, right? Okay.
I was just saying it should never depend on what the current state of your Wi-Fi. It's like you log in and you know this already.
I think you both agree. I think you're the same thing.
And so, look, I mean, I think I made my point there.
Yep. Abhishek.
Yeah, I think so. I think we need to look at practically what is going on in order to answer this timescale question. Otherwise we would be just theorizing that this could be the case, that could be the case. One way to do this would be to just look at at what timescale policies change. Some of the things we have seen is these policies change when, let's say, at least on the mobile network, when someone moves from 5G to 4G network, or these policies change when someone has a subscriber has exhausted their daily plan in some markets or monthly plan. So those are the kinds of timescales that we are talking about, and I think I agree with what has been said, that we need to appreciate that there is a difference between these timescales and the much faster congestion related and network condition changing kind of timescales.
Cool. So I think we have exhausted the queue with 5 minutes remaining and a great deal of really good discussion leading into this on the mailing list. I think that we might want to have more frequent interims coming up just to make sure that the mailing list discussion keeps going, because you could see the frequency of messages increasing greatly as as we got closer and closer to this moment. Marcus Christian, is there anything that you're looking for from the working group right now in terms of what you need to keep going? Or is this a let's keep this discussion going and there will be a draft we can discuss in Bangkok sort of situation?
From my perspective, I would like to know what, and maybe that's a question back to you or to the chairs, like what do we do? Like do we start a new document and add a bunch of pull requests to this document prior to making an adoption call, or should the previous authors sit down and make a new draft proposal and make that one as for an adoption call, or like what do we want to do?
Yeah, I think there's like I was like trying to figure out what I was going to say at this moment. I wrote this down earlier. I think it's pretty clear that what we want is going to be fairly train shaped, right? Like it's going to have some SCONE features potentially bolted, wedged into train. There might be some changing how we use the bits that we have. There might be some signaling that would allow us in certain situations to have more bits, but it's going to be very train shaped in terms of like how the syntax looks. That seems to me like there's kind of two questions we could ask. Like the one thing we could do is we just adopt train, right? And we say, okay, and then we're going to beat on it as a working group. I think I would prefer in that it is actually sort of like a merge protocol proposal for, and I think, if the authors of those two documents saw an email from me off list much earlier saying, hey, y'all figure out who, what, when. And then there's also sort of Martin Thompson's point. Sadly, he can't be here because the time really sucks for him. We will fix that next time. Of, hey, this isn't really super mergeable. You kind of have to start with train and modify it, which I think there's not a lot of contention about in the group of proponents. Correct me if I'm wrong, Marcus. I think we all kind of have gotten there.
Yeah, I mean, if that moves us forward, I'm happy with
Yeah.
it. Yeah.
So I mean, there's hey, we could either adopt train and then beat on it, or we could have the group of authors come together and put together a proposal based largely on train, but that is really meant as a discussion document. My bias with my chair hat on in terms of like trying to move things forward is for the second one. Just with the understanding that it's like, hey, this is a document that we're going to use as a discussion item, right? It's a thing that has a GitHub repository associated with it, with a bunch of pull requests, with a bunch of issues. I see a bunch of people getting in the queue, so I will stop talking and we can discuss.
Yeah, so I mean, I didn't see the discussion among the authors, but for me, this doesn't look like that we have something train shaped. I don't even know what you mean by that, right? So like, I don't see that conclusion.
Okay.
I think maybe we should consider at this point to just start a new document and actually name editors who are not any of the authors and merge things together where we have agreement. If the authors don't get their shit together and get like a merge proposal.
Okay, I think that would how to put it. I would say we can ask the authors, and then if in Bangkok we don't have that, then we could go with that option. Kristen.
I think what is logistically not too hard is to have a new version of train, which maybe we have some name change or whatever, but basically a new version of the train document with incorporating maybe an additional author and incorporating all the feedback that Marcus has been doing.
Is that something that we could pull together with? Is that something we could pull together before Bangkok?
I suppose yes. If we want to do it, we certainly can. But
Yes.
It's
like I would like a single document that we can discuss, and I don't very much care how we get there.
Yeah.
So, Matt.
Yeah, I mean, I was going to say basically the same thing as Christian. I don't really care how we get to a single document. I would just prefer that whatever we make an adoption call for actually addresses the points that have been raised.
Yes.
So it's like I don't think it's right to really make an adoption call on any existing document. Like there actually has to be some compromise.
Cool.
Otherwise, so.
Miria.
Yeah, if you really want to go for the train document and you want to add authors, I really strongly recommend to add both Matt and Marcus because they have put a lot of work into that. But then we're back also to the case where we have like 5 authors, right? So
some of the train author maybe you're willing to drop their names.
But again, I think you should try to figure this out, and if you can't until Bangkok, I think the chair should make a call.
Okay. Yeah. So, Marcus, Matt, Christian, Martin, please send us a document for Bangkok. You can reach out to us about getting on the working group, like GitHub, even though we haven't, that's just you can use that repo. Not necessarily we're adopting that yet, with the idea that that would be the thing that we would eventually adopt. And if we don't do that, then we will do something else. Is that a good resolution to this part of the agenda? Are we happy with this? Are we unhappy enough with this that you're going to yell at me?
That's fine with me.
Okay, cool. Thank you very much. Next up, let me remind myself what's next up. Yeah, Sanjay, perfect.
All right, so let me just get started. I think I'm about 2 minutes behind, so I'll try to move fast here. So my name is Sanjay Mishra, and I work at Verizon. So first, as a reminder to the section of the SCONE charter that says this working group aims to establish a mechanism for network elements capable of rate limiting UDP 4-tuple to communicate an upper bound on achievable bit rate. So this presentation will focus on bringing to the fore the network element that can be leveraged for SCONE signaling. So that's the theme here. Next slide, please. So I'm going to skip this one really quick. This is all the section. These are all the topics that I want to cover in the next few slides. So next slide, please. Yes. So this is the crux of my presentation here. So, and I hope to help shine some light on what specific network elements capable of achieving the goals of SCONE working group. And to that end, I'll keep the focus here on just the user plane function. So this UPF, or the user plane function, is a network element in the 5G core representing the evolution of data plane in the control and user plane separation strategy. What I mean is that the user plane function is a fundamental component of the 3GPP's 5G core network architecture. UPF is the data path between the end user and the internet, and has access to subscriber policy via standard 3GPP interfaces, and is responsible for forwarding user data packets. And as listed on the lower right-hand side, as you see here, some of the list of functions. This is not all comprehensive list, but just sort of gives you an overview of what UPF is responsible for. For example, it processes and forwards user data, such as voice and video, between the user equipment and the internet. It performs packet routing, forwarding, and provides interconnection to the data network or the internet, actually. Has control functions such as managing the flow control data between the UE and the network, including session management and policy enforcement. So that's an important part for us. It does QoS policies and handles traffic filtering. So to summarize, UPF is the anchor point between the mobile infrastructure and the data network. And to accomplish all of this, UPF has 4 distinct reference points as defined in the 3GPP architecture. And I want to kind of parse those out here. So if we sectionalize each of its interfaces, if we start with the UPF and the 5G base station as shown on the blue line on the left of the UPF. This is the N3 interface. The blue color is just to sort of show the path, that's all. Then there's a connection between the UPF and the session management function. This is the N4 interface. SMF is shown just above the UPF in the diagram here. And then we have the UPF connecting to the internet or the data network, which is the N6 interface. And then you have the N9 interface, which I've not shown here, but that is if you had multiple instances of UPFs, then you would have each UPF would talk to each other via the N4 interface. What I forgot to mention is that the N3 interface is the one between the UPF and the 5G base station. That's the one, the blue line that you see there. So from the SCONE discussion, the most relevant for us are N4 and N3 interfaces. So for example, the UPF identifies user plane traffic flow based on information received from the session management function over this N4 reference point. So the N4 between the session management and UPF learns through that N4 interface instructions on packet forwarding control protocol. It employs packet forwarding control protocol that basically provides information such as packet detection rules, forwarding action rules, buffering action rules, QoS enforcement rules, usage reporting rules, pretty much anything on the control plane that has the user plans and information is all what is communicated through the N4 interface. Now, on the other hand, N3 interface is between the UPF, the base station for the radio network, i.e. the G node B, and the UE. So if I were to break it down on a step-by-step, I would start with the user equipment on the leftmost side, which let's say generates IP packets for communication, web browsing, or video streaming. So these packets are transmitted to the G node B over the radio interface. The G node B is there encapsulating this user plane data using GTPU, which is the GPRS tunneling protocol user plane. And I apologize for all these acronyms because 3GPP is full of them. Now, the G node B forwarded this encapsulated packet over the N3 interface to the UPF in the 5G core. The N3 interface also carries QoS flow identifiers, or the QFI, assigned by the policy control function by the SMF, as I covered above. So the QFI ensures traffic is prioritized and managed according to the user's subscription and network policies. And then within the UPF, once it removes the packet, it removes the GTPU header, processes the packet, and routes it toward the destination, which would be internet or the enterprise network or cloud, whatever. Now, on the downlink side, the data flow is just the reverse of what I just said, where the UPF will encapsulate the data using the GTPU and then send it over the N3 interface to G node B, and then from G node B to the UE over the radio link. Now, also importantly, I think some folks touched about the user mobility and switching between the radio access technology, the RAT. So the G node B is responsible for the N3 interface is important factor in ensuring that when the user is switching between the different G node Bs between 4G or 5G, ensure there's a smooth transfer handover without packet loss or interruption when it switches between the radio access technology. So that's where the SCONE also plays an important role as to how that signal gets communicated. So to summarize this slide, the UPF is responsible for packet routing and forwarding, packet inspection, QoS handling, for instance, shallow packet inspection, deep packet inspection, traffic optimization, and inline services, NAT, firewall, DNS, and so on. And then the external PDU session manages for the connection to the internet. I'm going to pause here because I think I jumped over a few things here and said some things. So I want to make sure before we move on to the next slide, just want to make sure that if you have any questions. I see Kevin here.
Yeah, thanks, Sanjay. Yeah, Kevin Smith, Vodafone. Yeah, thanks for this. I think I could summarize this in my thinking is the UPF is probably the easiest place to do it. However, it is not close to the likely point of congestion, which would be the radio access network. So I'll be interested to know, as we explore this, what the trade-off is between it being easier to do versus information which isn't as fresh as it could be regarding the state of congestion and hence the potential throughput advice. Thank you.
Good point. All right, so let me move to the next slide. So essentially the same slide as what we saw before, but just sort of overlaying what you would have a SCONE path. So what this slide is suggesting is, in a nutshell, that you could write the SCONE signal over the N3 interface, connecting the user plane function, the Gnode B, and the end user. So that's really the highlight. And I know I have about a minute to go. So let's jump on to the next slide, please. So this is essentially the same thing, but showing how you can accomplish the same on a 4G network. So some changes in the terminology, but essentially the same concept. The next slide, please. So, this is important. What I want to communicate is that from the previous two slides on the 5G and 4G, what we saw, what I'm thinking is that this is the client app endpoint initiates the SCONE signaling to the network element, the UPF or the P gateway, with implicit flow detection. The UPF then sends the advisory bitrate to the metadata and the other metadata to the SCONE working group signaling to the client endpoint. And also the signaling, the SCONE part of it does not in any way impede or requires any changes on the CSP side as to how they determine and deploy their video policies. So this signaling is kind of independent of that. In fact, the messaging would be the result of what their independent policies are, and based on that, they can determine what they need to communicate over the SCONE signal. And then application will self-adapt based on the advisory bitrate. And I know there are things that are unknown, and I just put it out here that dynamic updates, and I think probably more experimentation and experience is needed to determine the frequency of updates and when should that happen, and how when the user is transitioning between the radio access technology. So I think I'm going to leave that open up to the working group to decide on this part. Next slide, please. This is just, and I know I'm out of time, so just really trying to convey here that there is no restriction on that this only applies to mobile network. This can also be extended to fixed wireless or fixed internet home services or satellite services. So sort of wanted to convey that point. And with that, I don't know if you have time, but I'm open for questions.
So one half of a question. Enter the queue in 5 seconds. Otherwise, Sanjay, I guess you're open for questions on the mailing list afterward?
Yes.
Excellent. Thank you very much for the presentation. Gone. Next
Thank you.
up, video session data rate. Dan.
Thanks, Brian. I will keep it short. Hopefully, people got the chance to read the draft. But if we go to the next slide, um, I wanted to frame the scope of the discussion with regards to this video session data rate. So as was already mentioned, we are talking about defining how we're going to exchange and what. And the what part is actually, in my opinion, broken down in two aspects: the formatting and the meaning. And the scope of the discussion for video session data rate is really on the meaning of the throughput guidelines. And it really should be defining the what it actually means, and an upper bound of that would represent the throughput advice. If we go to the next slide, the reason we need it is because we want on the CSP side, we want to make sure that we're sending a policy value that that is representative, but we also want to make sure that it is something that we can trust to be enforced, but we want to verify. And and for that, we also need to make sure that we're accounting for multiple flows and traversing the network at the same time with the same for tuple. Should we go to the next slide? It kind of answers why we don't want to use a single bitrate kind of a value, because in the current the video delivery systems, we have multiple video streams at the same time for enhanced quality of experience. There's a lot of prefetching happening, and besides just the the active video happening. And the other part is that CSPs can only see and count packets. So if we go to the next slide, I think what there's a lot of text in here, but it boils down to the fact that what we want is to count all the data within a certain time frame that is considered an active session, and basically divided by that duration, and that actually results in a value that then we can use to express a policy. And I think this is kind of going back to the discussions we had about the blob, because if you read the last sentence, a percentage of video to be delivered over video sessions whose video session data rate do not exceed a predefined limit for a given time frame, those are quite a few parameters that would need to be encoded into what that actually means, because that's what the network would probably signal. It's not just oh, don't go over this, and that's pretty much the gist of it. And if we go to the next slide, I'd like to go quickly, and maybe we have a discussion about this. It really is about talking scone to scones. I couldn't figure out a better way to explain it. Instead of apples to apples, we don't want to say on the application side, oh, this is what we think you're talking about, and on the network side. So it really is about optimizing the calculating it in a consistent way that CAPS can actually optimize their delivery. It's not about using the codecs itself, but it's also how to pace their videos, how to multiplex, to actually stay within that policy, and the CSPs to measure the data usage and verify the conformance with the self-policing. And this actually can be used with SCONE or with any other mechanisms. I know we had other ideas, maybe more sophisticated in the past, but in terms of where it can be used, I think this actually can be applied for other channels, if you want, if not necessarily related to SCONE, but it definitely is specific to SCONE in this context. And if we go to the last slide, I put a link to the draft, and I just hope we can get some feedback, some discussions. If this is necessary and useful, we can have another version by Bangkok, and then we can discuss where to take this piece of specification. So that's about it. I'm open for questions, and I think Marcus is.
Marcus, go ahead.
All right. Yeah. Thanks, Dan. I think this is great work. I think we need to start thinking about this. I definitely have had in mind that many network elements that want to do this, and with the expectation that you actually remove shaping, you need some way of measuring and monitoring the data rates and the throughput of the flow to see that the policies are somehow adhered to. I think on this specific proposal, I think it's going to be extremely important to define these idle periods correctly, because one of the very nice properties of disabling shaping while maintaining the bitrate policy is that you now allow the network, the application endpoints to transmit whatever data they have at whatever rate the network can sustain. And if that means that you can deliver your video chunks at very, very high rates, utilizing the network capacity fully, and then go into a slightly more idle mode, that is a very good net benefit for kind of the radio network. So I just want to make sure that when we design if we design some standard way of kind of doing flow monitoring, that we really take these considerations we take these aspects into consideration. Especially important is like for how long, like you said, you might not want to do like averages and so on, but at the same time, doing a simple average over some time window provides us with a very nice benefit that we can allow for quite massive bursting of packets and so on, and really fully utilize the network capacity. So that's just something we should think more about. And I will try to review your draft in more detail and go back with more comments. But I think it's great that you start this work.
Thank you. I do want to clarify. I see some comments in the chat, and Miria, you're absolutely right that video is so yesterday. But the truth is that this is how I use the example, because video is also the largest data consumer on the network, and actually it actually emphasizes the fact that we need another piece of the another element into the throughput. Is it applying to everything? Is it applying just to a subset of your traffic? Is it applying to a subset, but for a certain time frame and so on? So I think we need to look at some, and Abhishek, I think, mentioned that they have visibility into some of the broader sense of policies around the world. It will be interesting to see how we can express or gate some of these examples. And I mentioned requirements, but really what I didn't mean to go into a document specific for requirements. I think we need to put some things up front in the SCONE, TRON, whatever train specification, so we're not kind of stepping on each other about, should we do congestion, should we this? Does it apply to all the traffic and so on? But in any case, I do think that one aspect is what this policy applies to, and in this case, as Marcus said on the chat, is really adaptive bit rate video.
All right, Dan, thanks a lot. Thank you all for joining us here at various times of the day, wherever you happen to be. We've got 0 seconds remaining. I don't know, Jin, you want to make any last comments beyond see you in Bangkok?
Yeah.
And we'll take it to the list.
Yeah. Thanks everyone. We have a very good discussion. Actually, in addition, new proposal from Dan and Sanjay. Actually, we also encourage more people to review the SCONE experimental, on the mailing list to hopefully we can have more progress before Bangkok. Yeah, thanks everyone.
Thanks a lot. Have a great day.